Okay, so we are going to go over the Pythagorean theorem. So, the Pythagorean theorem works whenever you have a right triangle. So here is a right triangle. The side opposite the right angle is called the hypotenuse, and that stands for the longest side because it is the side opposite the biggest angle, so it is the longest side, and we call it the hypotenuse. The other two sides, and it does not matter which is which, are called legs. We usually call the hypotenuse C. We call one of the legs A and one of the legs B. So this is a right triangle. Hypotenuse is the longest side. The other two sides that lead to the right angle are called the legs. Okay. Now, the Pythagorean theorem says, so let me get rid of all this. We just know this is side A, side B, and side C, and that side C has to be the longest side, but we don't care which is A and which is B. The Pythagorean theorem states that A squared plus B squared equals C squared. So that means if you have a right triangle, and let's say this side is 5, this side is 3, and this side is 4, and this is a famous Pythagorean triple. If this is true, then we can say 3 squared plus 4 squared must equal 5 squared. And 3 squared is 9, 4 squared is 16, 5 squared is 25. And that works. 25 equals 25. Now, the kinds of problems you might see is they will tell you, okay, your two legs are 3 and 4. How long will C be? So to solve this, I say 3 squared plus 4 squared equals C squared. I'm going to square root both sides. And notice you can't square root 3 squared separately and 4 squared separately. You have to square root the sum of the two. So 3 squared is 9, 4 squared is 16, equals C, because the square root of C squared is C. So this becomes the square root of 25, which equals 5. And I'm not going to say plus or minus because it's a side length, therefore it has to be positive. And so the Pythagorean theorem can be applied to any right triangles, and it means if you know two sides of a right triangle, you can always find the third. So now in your packets, I want everyone to turn to page 24. Okay, turn to page 24 in your packets, and we're going to go over a few examples. So here is the example I showed you at the top of this page. We're going to do number 1 together. So number 1 gives you two different legs, and it wants you to find C. So you say 3 squared plus 6 squared equals C squared. And 3 squared is 9, 6 squared is 36, equals C squared. I add 9 and 36 together, I get 45 equals C squared. So I take the square root of C squared and the square root of 45. Square root and square cancel each other out. And I don't say plus or minus 45 because we're talking side lengths and we're only interested in the positive. Now I can simplify this radical. So I say it's the same as the square root of 9 times the square root of 5. And the square root of 9 is 3. So my answer is 3 root 5. Okay? And now, number 2, the hypotenuse is also missing. For number 3, the hypotenuse is missing. For number 4, the hypotenuse is missing. Let's look at number 6, because number 6 gives you a hypotenuse, but asks you to find the missing side length. So again, it could be A, it could be B, it doesn't matter. A and B can be interchanged. So to do this, I say A squared plus 8 squared equals 11 squared. So A squared plus 64 equals 121. A squared equals 121 minus 64, so that's 757. And I take the square root. So A equals the square root of 57. Now 57 is divisible by 3. 3 goes in once. 3 goes into 27 9 times. Those are both prime. So the square root of 57 cannot be simplified. So, oops. I'm just trying to see if that's the right answer. I don't have the right answers. We'll assume that that is correct. Okay, so you go ahead and finish this page.